Hello, welcome back to my YouTube channel. In this video, we're going to be looking at Visual Language Model BLIP-2. BLIP-2, which stands for Bootstrap Language Image Retraining 2, is a visual language model which understands both images and text. This model was developed by Salesforce and it leverages state-of-the-art techniques in computer vision and natural language processing. For instance, with Visual Language Model, it makes it easier for you to transform your photo collection into a narrated gallery or making your e-commerce site more accessible and engaging with automatically generated image description. So we're going to discuss the architecture of BLIP-2 and we're going to look at what it entails. BLIP-2 has three main parts: the vision encoder, the Q-former, and the large language model. The vision encoder is pre-trained to understand images. It's a pre-trained model that turns an image into numerical data that the AI can work with. While the Q-format connects the vision and language together, it takes the image data from the vision encoder and figures out which parts are important. Then it translates that into a compact format that the large language model can understand. The last one, which is the large language model, is a powerful text generator that can write natural responses. It receives the visual summary from the Q format and uses it to answer questions or describe the image. Both the vision encoder and the LLM are frozen, which means we can't retrain them. Only the Q format is trained. This is an example which demonstrates how BLIP-2 processes an image to generate a meaningful answer. Now we're going to look at the Q format and we're going to discuss the training strategies. The Q-format, known as the query transformer, is an enable model which bridges the gap between the frozen image encoder and the frozen LLM. It is pre-trained with a two-training strategy. First is the visual language representation learning, while the second is the vision-to-language generative learning. So we're going to discuss each of these. The first one, which is the vision-to-language representation learning. In this stage, a visual language representation learning is performed, which enforces key format to learn visual representation most relevant to the test. It uses three different complementary objectives. So the first one is the image to text contrastive learning, and the second one is the image to grounded text generation, while the third one is the image to text matching. The first one, which is the image to text contrastive learning, in this learning, it aligns image and text embeddings, which helps the key format to learn general alignment between images and text. For instance, it's like matching a photo of a dog with a cute puppy and not a red car. While the image to grounded text generation, it describes what you see in the images. It teaches key format to extract the most useful visual info for generating languages. With image to text matching, it helps key format to learn detailed and prescribed connection. What it does is to ask questions like, do this image and the caption actually go together? So now we're going to discuss the second step of the pre-training strategy. The second step, which is known as the visual to language generative learning. In this stage, it connects key format to a frozen LLM and it trains the key formats to whereby the LLM can generate the required text. So to summarize everything that we've learned today about BLIP-2, we're going to look at the real-world application of BLIP-2. So we can use BLIP-2 for image captioning, and we can also use it for visual question answering. It can also be used for instruction following image to text generation. So now that I've discussed BLIP-2 and its architecture, so now we're going to write a code to demonstrate how it actually works. So for our code, we're going to be using Google Colab to demonstrate. Then these are the things that we did, which is to first install all the required libraries. So where we're going to install transformers, touch, and pillow, and the others. So, and where I just try to bring in my files. So after then, I'm able to import all the required libraries. So where I'm importing the BLIP-2 processor and the BLIP-2 for conditional generation from transformer. So after then, we have both the BLIP-2 processor and the conditional generation. So we're going to load the model and processor, so which is what I'm doing here. So also, I try to see if I can use the GPU instead of the CPU, so on Google Colab. So at this point, so this is where I actually load the image. So this is the sample image we're going to use to demonstrate. So which is we want BLIP-2 to actually give us a caption for this particular image. So what we're going to do is we're going to pre-process this image by passing it through the BLIP-2 processor, where it actually resize it and also convert it to tensor format, which is what the model expects. So after we've been able to pre-process the image, then we are going to come down here to actually generate our caption. So there are a couple of things that we need to do. So first, we're going to run the model to generate text token by using the inputs that we pre-processed earlier. And as well, we're going to convert the generated token ID to human readable text. So which is how we're able to generate our caption. So if you look at the image We can see like these are actually ballet dancers. Then we're going to see what the model actually generates as a caption. So if we look at the caption, it actually gave us young women in ballet class in a dance studio. So which actually gave the right description for that image. So we can see like the model is able to generate the right caption whereby not returning something that is random. So it was able to look at the actual thing that is happening in the image and give us the right caption. So let's load the second image. So we can see this image. So they are all from Unsplash. So we can see this image is actually two people that are kind of cooking. So we really don't have any idea. We just know like there are two people there that are cooking. So let's see what the model generates for us. So you can see just like what we did earlier, we first process the image and also we generate text tokens. And after that, we're able to generate a caption. So if we look at the previous image whereby we have those people cooking. So this is the caption that the model returned. So it said a couple in the kitchen preparing food. So it's actually able to capture the scene and let's say the context of what is going on in the image before it was able to generate the caption. So we can see like the BLIP-2 model is very good in generating caption. So, and it can be used for business use case. Let's say you want to generate caption for an e-commerce website or any other thing that involves captioning of an image. So BLIP-2 can actually come handy. So this is the end of this video. If you found this video helpful, please give me a thumbs up. Also subscribe to my channel so you can see related videos like this. Thanks for watching. I would love to see you next time.